Okay, now we're going to talk about extraneous solutions, which sounds very kind of scary and malicious, but really it's just something that happens when radicals are involved in an equation. And I hinted at this earlier. We talked about it very briefly. I did some hand waving to make it make sense. I thought it was the last video, but then I haven't looked. It may be just a previous video. I don't think it was the exact last video. It was the video called Radical Equations. I talked about it briefly, and I said, here you've got two solutions to this equation, but one of them doesn't work, and we just check it, and we check them both, and the one that doesn't work we say is extraneous. So I just did some hand waving and expected you to just accept all of that as fact, and I didn't really tell you why. And that was because it really deserves its own video, which is why I'm making this video. So now you actually get to know the reason why there are extraneous solutions and how to deal with them. So I want to go back. We're basing this on this radical equations video that you've already watched. So I went back there and I pulled two examples. So I did these two examples in that video. Okay, and I'm gonna do them again, but I'm gonna do them again, and then I'm gonna tell you how this fits into this question of extraneous solutions. So here's the first one: 4 equals square root of n. Well, what we're going to do to solve this is, of course, we're going to square both sides. And notice here that we are squaring the only n is under a radical. So we're not actually making this into an n squared. We're not ending up with a squared variable. We have a squared constant, but that's okay because squaring a constant just gives you another constant. It just gives you a 16. And then squaring a square root of n just leaves you with n. So nowhere in any of this is the n ending up squared. Notice the n just has a exponent of 1. But here what happens is, when we are squaring, of course we have to square that, but that means we also have to square this. What ends up here is that we are ending up with x squared, which means we are making this into a quadratic, which it isn't. That should be a comma, which it isn't. And in doing that, we create this kind of parallel universe where, because a quadratic, as we have learned, and as we have studied, the quadratic is going to have two solutions. The quadratic will have two solutions. But my actual, and I'll call it my original, equation only has one because it wasn't a quadratic. So in the act of squaring it, we're making this original equation into a quadratic when it's not really a quadratic. That means when we get that x squared right there, we're automatically going to have a second solution that mathematically comes out of it. And there's nothing incorrect about the math that gives us the second solution. The issue is here where we're squaring it. We're squaring it as a matter of convenience to pull this x out of the radicand. And by doing that, this side of the equation is okay. The problem is that we have this x over here that's not under the radicand, and by squaring that, we're making this into a quadratic, which it's not. So we have to just keep in mind that anytime we're doing this whole squaring and square root thing, things can go a little wonky, and we just have to be careful and pay attention to what we're doing. So that is why this one ended up with an extraneous solution. So let's just go through that real quickly here. So I've squared it, and I've gotten x squared equals 90 minus x. Well, here's my quadratic. If I solve this for 0, I've got this. I can do factoring pretty easily on this, and you'll get a negative 9 and a plus 10. And if I hadn't seen that, I could have just done the quadratic formula, and I would still have gotten that x equals 9 and x equals minus 10. But the fact is that we're getting two answers out of this, and only one of them is actually going to work in the original non-squared thing. So I want you to just keep in mind both of these. So these are both valid solutions. Both are valid solutions to the quadratic, which was here, right here. Okay, or there, same thing. They will satisfy their solutions to that, but that's not my original equation. That's my original equation, and only one of them will work successfully up here. That's why we have extraneous solutions when we are solving some of these radical equations. Okay, so let's do an actual example of this. Okay, so here's an example. Okay, let me get lined up here. Example. The example is going to be 4 plus square root of x plus 2 equals x. Okay, so we can isolate the radical before we square it, so subtracting 4. Okay, and then we square both sides. Notice the right hand side you're going to FOIL. Right? X squared minus 8x plus 16. Now let's solve for 0. Solve for 0 because now we do have a quadratic. Notice here this is a quadratic. Now it's quadratic. Okay, so we solve for 0. I'm going to move these terms, collect them over on the right hand side. So we're going to have minus 9x and plus 14, right? And so I can factor this. I notice this is easily factorable by x minus 7 and x minus 2. Okay, so that means x equals plus 7 and x equals plus 2. Both back into the original equation, and it's important to plug it into the original equation. If you plug it into, after you've squared it, which was the second step that we did here, if you plug it into after the squaring it, they're both going to work because these are valid. These solutions are valid here and then everywhere else down here. Okay, so the squaring is where the cutoff point is. So you have to go back to the original. You have to go, I'm going to do green for go here. You have to go back to the original, check for extraneous in original EQN. Okay, original has to be the original one. Alright, so let's plug in the 2. So we're going to check x equals 2, and we're going to check x equals 7. So if we check x equals 2, our original equation would be 4 plus root of 2 plus 2 equals 2. Alright, so that's 4 plus root of 4 equals 2. 4 plus 2 equals 2. 6 equals 2. So that is a contradiction. That's a contradiction. So therefore, thus x equals 2 is extraneous. Now, but I'll just show you that if we plugged in the 7 here, are going to get that works. So thus x equals 7 works. So what does that mean? That means that in our original equation, okay, our original equation back up here, this 4 plus square root of x plus 2 equals x, that original equation. So the solution there is x equals 7. So this one works. So this is the solution to our original equation. That's the solution to our original equation right there, is x equals 7. So now let's do some examples on the homework type examples. Okay, so this is what your problem set will look like. Okay, notice that here I'm not going to have any extraneous solutions because the only thing that is being squared is the the only place that the variable exists is under the radical. I'm not going to end up with a quadratic here, so I'm not going to have anything extraneous. So if we just divide by the -4, which we need to do because we got to isolate that radical. So this is going to be 2 equals root of k plus 5. Now we square, and see I'm not going to end up with a quadratic here. So 4 equals k plus 5, subtracting the 5, so -1 equals k. Rest of them on the front of this is going to be the same as that. Let's even do this where we've got variables on both sides, but they're both under a radical. We can immediately go into squaring. Notice we're still not going to get any quadratic out of this because everything is under the radical. Okay, and then we'll combine. I'm just going to collect the x's over here, so this will be a -2x, and collect this -10, so x equals 5. Okay, pretty straightforward. Let's do one where no, those are all the same. Okay, let's do a basic one here. Notice that I've got an x, here I've got an x in the radicand, so that is going to give me an extraneous solution when I square, because then I end up with that, right? And so when I've got a quadratic now, so I have to solve it for 0, and I can use any of my quadratic techniques that I want to try to solve this. So what I notice here is that I can just factor out we've seen some of these before. I can do a GCF factor and get this, right? And so by zero product property, that means that x equals 0 and x equals 4. Okay, but now I want you to be careful with this, because every once in a while, if you have a situation like this, it's a little bit special. Both of the solutions will actually work. Okay, so you just have to be careful that you're not just assuming that something's going to be extraneous. You really do have to check everything. So if we plug both of these in, let's check x equals 0. Then we're going to original equation. Okay, so this is going to be 0 equals a square root of 4 times 0. 0 equals the square root of 0. 0 equals 0 is good. Let's check x equals 4. Check x equals 4, so we have 4 equals the square root of 4 times 4. 4 equals the square root of 16. And this will work also. And by the way, we're assuming here, like, you can say, oh, well, the square root of 16 also equals negative 4 because negative 4 times negative 4 is 16. Yes, that's a good point, but for the sake of this, we're just checking to make sure that it doesn't come up with an obvious contradiction. So that is not a contradiction, it works. If you ended up with, square root of 16 equals 3, that's an obvious contradiction. So there's that. Now I want to look at this one here, number 15. This is also going to be a special type of thing. So I want you to just watch me go through this and pay attention. So we're immediately going into the squaring phase. So we have this. Okay, we've got a quadratic. Now we have to isolate. To keep my quadratic term positive, I'm going to collect everything on the right. So that means I'm going to have n squared plus 2n plus 1. And so now let's look at this. So we have n plus 1 and n plus 1. Okay, and that'll give me plus 2n and plus 1. So there's my factorization. That's a squared, obviously. So I only have to check. That means that this means that n equals negative 1. So I only have to check one thing because they both of those roots give me the same answer of n equals negative 1. But when I notice here, I notice what I've got. So when I'm checking, I've got a big square root equals negative 1. That's a problem because I can't get a negative out of this. Do you see what I'm saying here? Look at this. Negative 1 minus 2 times negative 1. Okay, so the square root of negative 1 plus 2 negative 1 plus 2, right? So then we've got a square root of 1 equals negative 1. And I mean, you can say that, yeah, negative 1 times negative 1 equals 1. But essentially when we're talking about this square root situation here, for the purposes of this class, we're talking about the positive square root. So we're going to call this no solution. Okay, that's going to be no solution because the negative 1 did not work, so that gives us a contradiction. The negative 1 did not work. That's the only thing I had to go on, so therefore I have no solution. All right, let's do another one here. Let's do another one here. I'm going to move to the back. Okay. So let's do number 19. Okay, let's do number 19. Actually, no, let's do number 22. I like this one better. Let's do number 22. So we've got a radical plus 2. We've got to isolate the radical by subtracting the 2. So that's going to give me square root of 19 minus 2p equals p minus 2. And then if I square everything, I'm going to have 19 minus 2p, and then this will be FOILed minus 4p plus 4. And then I've got to collect everything. I'll just collect everything on the right. It seems a little bit easier. So I have that, adding 2p, and then subtracting a 19, I have that. So then here I've got p, I can see, how about a plus 3 and a minus 5? That should give me yeah, it'll give me negative 2p and a negative 15. So then I'm saying here that p equals negative 3 and p equals positive 5. So checking, I'm just going to come over here and use some of this space. Checking p equals negative 3, and here I'll check p equals 5. So when I check p equals negative 3 in the original equation, I'm going to have square root of 19 minus 2p plus 2 equals negative 3. When I check 5, I'm going to have 19 minus 2p plus 2 equals 5. So I just keep that separate right there. Okay. And then, so here, what do I have under my radical? That's going to give me a plus 6. 19 plus 6 is 25. So again, we're talking about the positive square root here. This is 5 plus 2 equals negative 3. 7 equals negative 3. Now, look, I mean, if we had just bended our rules to say it could be negative 5 right there, negative 5 plus 2 would equal negative 3, which is why you have to be so careful with this. We're talking about positive, what's called the principal square root here. Okay, and then so that's a contradiction, so that one won't work. Here we've got 19 minus 10 plus 2, and maybe you see where this is going. So this is the square root of 9 plus 2 equals 5. 3 plus 2 equals 5, so 5 equals 5. So that one's good. So p equals 5. That's our good solution here. That's our good solution. P equals 5. This one is extraneous, so that one does not work. The last one I want to go over really quickly is number 24 here. Okay, let's just barricade that off. I want to go over 24. We can start out immediately by squaring. Okay, so here we've got n squared minus 2n plus 1 equals 2n minus 2. And then collecting everything over on the left seems easiest, so we're subtracting 2n and we're adding 2. So here I notice I've got n minus 3 and n minus 1. That'll give me minus 4n plus 3, so n equals 3, n equals 1. So let's check n equals 3 and check n equals 1. So n minus 1 equals root of 2n minus 2, and n equals 1, so 1 minus 1 equals root of 2n minus 2. So that's 2 square root of 6 minus 2 is 4, 0, and that's 0, 0 equals 0, and 2 equals 2. They both work. Both work. So they both are good. Neither are extraneous. And occasionally that will happen. So you can't just I may have misspoken earlier in the video and said that you're guaranteed to have one of them extraneous. That's not true. There are different parameters that will give you extraneous versus not extraneous, but for the sake of this class I want you to just get in the habit of checking everything always just to make sure if it's extraneous or not. So there's a good kind of sampling of different types of problems where you get different types of answers. So the bottom line is, if you end up with one of these situations where you started out with not a quadratic, and then through your squaring stuff, through your algebra, you ended up with a quadratic, be in the habit of checking your solutions, because one of them may not work, and that's when we call that one that doesn't work extraneous.